It's always exciting to see if it works, and it seems to work. Yes. Hi, hello everyone again, and welcome to another Saturday live stream. I see that a lot of you have already joined in. It's great to be here again. And as you can see, my table today is a little bit a mess again. Last week I gave you a quick overview over different mobile phone adapters, and today I want to show you how it's possible, or different possibilities on how to connect a DSLR camera. Like this one is a pretty old one already. Doesn't matter. The principle is the same. How to connect one of those to a microscope. So I'm going to be showing you some adapters which are good, some adapters which are not so good, and some adapters which is just plain weird. I really have to say it like that. However, I'm not going to show you. We're not going to be looking at specimens directly through one of these DSLR adapters. It's a little too complicated to connect it. But I've got a DSLR adapter actually on my main microscope as well. So that's the first thing I want to do is I want to give you for, I don't know, 20 minutes, half an hour. We have a very, very loose time plan. And then, yeah, I know you're going to feel bored a little bit, but I'm going to show you again a couple of my worms. There's a reason for why, because later on I would like to feed them using some stained yeast cells with the hope of seeing them digest the yeast, number one. And number two, I also want to show you a little bit how to make a micro aquarium slide. Maybe some of you have already watched my previous video. Okay, so that's kind of a little bit the overview, and I'm going to use again the first 2 or 3 minutes to say hello around the world. From North Carolina, from the Netherlands, okay, from London, from Northern France, from the United States, in Florida, England, from Poland, from the UK again, from Greece. Okay, yeah, I have worms. Oh no, Oliver has worms. Yeah, those Iolosoma worms are quite nice to look at because they're fairly large. And I know, yeah, I've got a lot of them right now in the jar. But I do want to show you something a little bit today that I have also not tried out yet. So it's the feeding of them with the stained yeast, and in the hope that we're able to see them actually the digestive system a little bit better. I don't know if it's going to work. Okay, so. First of all, why am I actually showing you those adapters here? First of all, yeah, it has been a request, number one. Number two, it's not the first time that I'm actually showing you those adapters. I've already made videos in the past, previously already. However, every time when I show them to you, there are a couple of minor variations to it. Today in this video, I just want to give you a little bit of an overview of what I've got here. And some of the things that actually work well and some of the things that don't work well. So first of all, and maybe it gives you a little bit of an orientation here. So this is basically a camera that I've been using. It's a 600D Canon EOS, honestly pretty old already. However, this camera has a huge advantage. Look what it's able to do. It's got a flip out screen, and this already makes life a lot easier. Why? Because if you mount the camera on a photo tube, and I only recommend that you mount them on a trinocular photo tube, because otherwise the microscope might tip over. You can actually flip it around so that when it's vertically attached, then you can still see the screen. So that's a huge advantage. And another nice feature of those is, of course, you can record videos and pictures directly into the camera. This means you have a very high frame rate, which is not going to be possible always with USB. And you can also, of course, connect an HDMI. So, for example, if you want to connect the camera directly to a monitor without a computer, then this is also possible. However, I'm also going to show you a second, slightly cheaper way on how to do that. So those DSLR cameras, besides image quality, do have a few advantages. However, there is a huge disadvantage, and that is connecting it is not always easy. You do need an adapter. Now you're going to say, well, then we just get an adapter. Well, not all adapters are quite good. This one here seems to be working quite fine. Okay. Yeah. By the way, before I forget, there is a chat on the side. I'm going to resort this. I go to live chat so that the sequence is correct. Please do the following. If you have any on-topic questions, then please say @Oliver or @Microbehunter, so it's easier for me to find them, because it does take me some time otherwise to read it. Okay. And the next thing that I would like to ask you, if it's an off-topic question, maybe you can also indicate off-topic. It's been a request from my son because he is going to copy paste all of the off-topic questions again and to give them to me later after approximately 1 hour to answer them. And he complained a little bit. Rightly, he complained because I'm already answering all of the off-topic questions in advance, so he has nothing to do in that sense, right? So what I would like to ask you is please indicate this, please if it's something for me or if it's off-topic. So I just want to show you very briefly, and maybe some of you already know this, but it doesn't matter if maybe it's going to be useful anyway. I'm going to remove this here. Something that's really important is the following, and that is quite important. As a matter of fact, when you get yourself an adapter, you have to get yourself a camera-specific T2 ring. It's known as a T2 ring or T2 adapter ring, and this one is camera-specific. And they mainly exist, or not mainly, but they're quite commonly or more easily available for Canon and Nikon. And of course, you have to be careful that there's a difference between mirrorless cameras and the regular DSLR cameras. If you're using a mirrorless camera, which are quite popular these days, then those rings will be significantly thicker. And the reason is because the sensor distance has to be adjusted. So this is quite important. And then they're connected to an adapter. And this is an adapter that I bought online. And I'm reasonably satisfied with it for the following reasons. It's not too big and it does its job. Okay, so that's basically what I just want to say. It does its job. It's not I would say probably not the best one, right? But it's okay, right? I need to say something a little bit about the magnification here. It says here 2x, 2 times magnification. Now, the magnification of this optic is important because it adjusts the image that comes from the microscope to the sensor size. Because if you have a sensor which is fairly large, and here you see the mirror, so I'm not, the sensor itself is approximately the same size as the mirror. So this mirror is actually larger, or the sensor in here is larger than the diameter of the tube here. And therefore, we have to make it, the image, we have to make it larger so that it will fill the whole sensor, right? If you, however, have a camera which is smaller, like for example, I've got here a USB camera, which I'll also show you how this works later. Okay, you're going to see that the sensor in here is smaller than the diameter. Here it's definitely visible. In this case, what you need is you need an intermediate optics that are reducing, and this one over here is, I don't know, 0.5 times. Okay. Yeah. So I just want to say this. This is important because some people think that the magnification over here kind of makes the image always larger. No, the point of the of this optic here is to make sure that the image fits on the sensor, right? So that's why you need these optics here, right? It is also possible to connect it without intermediate optics, and I'm also going to talk about that. Okay, so very briefly, I'll just put this away here. Those adapters can be, of course, bought online, and you have to just make sure that you're getting the one, either for Canon or Nikon. But these two T2 adapter rings can, easily be bought separately. Okay, so just wanna say that. So that is essentially one that works reasonably well, basically, if you want to use that, then you can simply connect it over here. And the nice thing about that is that, of course, the camera can then also be used for regular photography, if this is what you want to do. Yeah. So then it goes on top of the microscope like this. However, I've got a few other things here that I just want to show you a little bit, simply so that you have a little bit an overview of what's available. This is not the one that I started off with. As a matter of fact, back when I bought my first microscope in 1998, wow, this was some time ago, I got this one over here. Okay, this is a huge thing, and this is still available secondhand, and it ain't cheap. Okay, but honestly, even though it's for the Olympus microscope, it also works for other microscopes as well. And I just want to show you the system over here. This here looks very familiar, right? This is again this T2 adapter ring, camera specific. Okay, and I'm going to take this apart now, just to show you what's in here, because the system is a little bit different, but the principle is the same. And this goes on top of the microscope, and look what I've got here. Yeah, this here is from Olympus, the NFK optics, 2.5 times. And this is a so-called a photo projection eyepiece or photoocular. Okay, it's kind of weird that they call it photo eyepiece, even though it's not an eyepiece for looking through. And they can be pretty expensive depending on the magnification, because this one here, the 2.5 times, is actually intended to be for a full format camera. Full format means 36 millimeters, like the old slide films. And so this magnifies quite a bit, 2.5 times more than the other one that I just showed you. However, many modern cameras like this, they have a much smaller sensor. And you have to, ideally, you would get one essentially which does not magnify as much. But I found out that those eyepieces are extremely expensive. I found a few of those, just one eyepiece around 600 euros. Yeah, because they were why? Because essentially they were because they fit the smaller sensor size. And I think when they actually made those eyepieces back in the day, long time ago, they did not anticipate maybe that the modern DSLR cameras actually have a small sensor, right? So those are cheaper for the full format, but for the small sensor, which actually would fit the modern cameras, or many modern cameras, are actually much more expensive. And those photo projection eyepieces, they have actually another unique feature, because these are so-called compensating eyepieces. It's kind of weird to say eyepiece. It's not an eyepiece. It's actually for projecting an image onto the sensor. Compensating means that you see there are all these lens areas like chromatic aberration and whatever. And those eyepieces are designed, if you have the Olympus optics in this case, to correct all of these mistakes. So, for example, field curvature, there was the problem that maybe the edges were kind of blurry. And the eyepieces are actually, these projection eyepieces are actually designed to correct all of those errors. Yeah. So they're pretty cool in that sense, and they have given you a lot of basically very good image quality. So if you've got the cash available and the patience to actually buy those, find those parts online on eBay or so, then I can actually really recommend those. Right, and I know that this is one web page, and I forgot where it is, which really documents this quite well. Yeah, and they've actually got different eyepieces for different cameras and so on. Yeah, camera sensor sizes. This one that I have is for full format. Yeah, so I'm very happy with this, and it also works extremely well for how do you say, for the non-Olympus optics. Yeah, so I've been also using this for my stereo microscope and so on. By the way, another thing that I don't know if you're able to see this. It's a little too dark. Maybe let me turn this on here. Yeah, the light. Do you actually see that there are so-called baffles in here? That means they have also a system to reduce internal light reflection. Here, that's a baffle, right? So to prevent light reflection and stray light. Yeah, so this is a pretty high quality thing. Yeah, very, very happy with it. Yeah, but again, not easy to obtain. Yeah, and it's a little bit bulky as well, actually. Yeah? So basically, the same one, almost the same one, is this one over here. Look, just almost looks like the color is different. Okay. The question is, can you retrofit an actual eyepiece in some way? Yes, I have done it as well. Yes, that's actually indeed correct. I have also done this trial. I tried it. Because this actually does work like a regular eyepiece. Yeah, if you look through it, you're just gonna see the image just like in the regular eyepiece. Look, you can actually put another eyepiece in here as well, and I also got it to work. Yeah, but those eyepieces are not compensating eyepieces. It would be kind of interesting. Maybe that's another little project to kind of compare this a little bit, the image quality. Yeah, but yes, it should work. And by the way, I didn't think of that. I mean, what about trying, I don't know, 25 times magnifications, or I don't know, different magnifications? I never thought about that. That would be actually quite interesting to see, to try different magnifying eyepieces here. Yeah, but actually this works, but this one here is as I mentioned already, a compensating eyepiece, right? One that actually corrects, one that has been designed for photography. Okay, honestly, yes, Jesse Eversmaller would be very interested to see a comparison. Honestly, I didn't think of the possibility until just now. So you see, sometimes I also get some interesting ideas. Right? So I'm going to show you this one over here. Actually, pretty much the same concept. I mean, it's the same thing almost. Okay, almost. Let me open this here. Because same thing over here. This one is a little bit the older model, yeah, but exactly the same principle. Okay. The other one is called NFK, and this one is called FK. I don't know the exact differences. It works just the same way. However, I just want to show you something different over here. However, this one over here came. Okay, and I'm going to detach this first here. When I got that, it came only for an Olympus camera. So I could not connect my Canon to this because this is for the Olympus OM system, so the analog Olympus camera back from the day. I said, oh, gee, what am I going to do now? And then luckily, I was able to find, I could not believe that this actually exists, a one that converts from the OM system to Canon EOS. Yeah, so this is a ring that goes on here, yeah, which was actually separate from the adapter, yeah, and it snaps in place, yeah, and apparently also all of the see, there's even a lever over here for the camera settings and so on. Yeah. So otherwise, it's the same thing. But I just wanted to show this to you that this is something that I had to get extra in order to be able to use this. Yeah. Otherwise, it's exactly the same thing. Yeah. So those adapters, if you're able to get them secondhand, and if you have a Canon or Nikon camera, yeah, then this is also certainly a possibility. However, they are heavy. Okay, and I think the next thing that I really have to try, honestly, I think I really have to try whether I can use regular eyepieces if they also give a good result, because this would actually really save a lot of money. Okay, and thinking about that, I'm just thinking about that. If we measure this out, we could 3D print this here. I mean, that would be possible. Regular eyepieces maybe, and then we just measure this out, and then we 3D print the whole thing. And you could actually make your own DSLR adapter. And here at the top, what do you have? Here at the top, you put in this T2 adapter ring. Yeah, this one over here. Yeah, that would be actually also a possibility. Because this is just a tube. Yeah, we don't even need the different parts here. We can actually, if you're somehow able to do this and print this in one piece, it should actually work. What's important are the distances. That's important. The reason is because we want to have parfocality. We want to make sure that when it's in focus through the eyepieces, that it's also in focus here. Yeah. So that would be interesting as well. Okay. So these are actually the things here, and I just want to show you a couple of others as well. Every now and then. Every now and then I'm going to quickly also check some of the comments here. Yeah. Don't even need the T2 adapter ring. I have 3D printed adapters for my Nikon that uses a bayonet, and the printed ones work just fine. Interesting. Okay, thank you. So maybe on Thingiverse or on other places, maybe they even have those, I don't know, just readily designed adapters for Canon and Nikon and so on. And then maybe you can just kind of connect them. That would also be possible. Yeah. I've not tried. I always thought it might be a little bit too difficult to 3D print those. Yeah? So talking about 3D printing, if you also search on this how do you say, in this channel, there was also a microscope a couple of years ago actually, where I 3D printed this adapter here, and this one here at the top is also a T2 adapter. It's a little bit wobbly because I did not tighten the screw, but it's just a regular tube. Which can go on my microscope. And here, there are no optics in here. Okay? Because this is for so-called for direct projection. It is possible, it is indeed possible to use the objectives directly to project an image on the sensor, provided that the distance is correct, right? And this actually also worked quite well. And surprisingly, maybe because of the large diameter, and I don't know, surprisingly, I was able to fill a full sensor. So this is actually like if you're using an adapter without optics, then it is just like using intermediate optics of 1x. Yeah. So, and this actually also worked. And yeah, the only thing that I had to play around a little bit is to a little bit by trial and error is to get the distance correct, so that it's parfocal. It's a little bit off, I think. Yeah, but the idea is that when I connect it to the microscope, that I want to make sure that it's in focus both in the camera and also in the eyepieces. That I do not have to refocus too much. Otherwise, there's always the danger of maybe crashing the objective into the slide. Yeah? So that is a homemade solution. Here now it's off. Yeah, that's the T2 ring, but without the without the part on the inside. Yeah, there was also an inset that I removed so that I can directly connect it here. And yeah, as you see, I've also got screws here. I did not print this in one piece, but in several parts, so that I could reuse those parts if the length of the tube was not correct. So again, it's a little bit of a prototype, but it works reasonably. Works not only reasonably well, it actually quite well. The thing that I like about this here is that it's significantly smaller, right? However, the microscope also allowed me and had enough space so that I could actually directly connect something, because many microscopes have this long photo tube, and this microscope luckily had a very short one, and therefore I could directly connect it. Yeah. Yeah, there are a couple of nice comments here as well. Okay. Yeah. This was the eyepiece question. Yes. So I'm going to show you something else here, a few more things. Over here, look at this. I need to take this here off. Look what I got here. And this is an experimental solution, I just want to say. I'm going to remove the T2 adapter ring. Look what you can do. How is that? You get the idea. This one here can now be directly inserted into the eyepiece, and this is a cheap solution, and it's an emergency solution. What I would say is try it out because it's so cheap, and if you're able to get the parts. The reason why this is an issue is the following. There are really two reasons for it, and they're maybe not big problems, okay? Number one, look, it's so small, it's not able to fill the whole sensor, because the sensor will go a little bit, outside. So that means you have some kind of dark corners, and those dark corners, they basically block a little bit the field of view. However, because you have a DSLR camera, there is still quite a lot of sensor that you just have to crop in, essentially. So that is one slight issue that would not really bother me too much, because I usually edit the pictures afterwards anyway. Right, so I just crop in and just take the central part. So I don't care if the edges are kind of black or blurry. But the bigger issue rather is the following, and that is that you have to really refocus the microscope, because the thing is the following. You see the camera sensor. You have to understand the following. When you connect this over here, the camera sensor is behind here somewhere, right? And this is where where it's connected either to the eyepieces or preferably the photo tube, otherwise it might tip over. However, the microscope will actually project the image from the objective down here, up to here, right? And I have to refocus. It's approximately a centimeter down into the tube. This is where the eyepiece picks up the image. It's approximately a centimeter of from this edge over here into the tube. This is where the image is made by the objectives, and this is where this eyepiece picks up the image. Right, and this also over here, it would the image would be projected over here. And however, the sensor is on over here, so I have to kind of refocus it to move back the focus plane all the way, I don't know, 5-6 centimeters. And this means I have to really refocus the microscope, and this can be a little bit tedious if you don't know into which direction to turn it, and then you lose the focus because it's not parfocal anymore, right? So, but I mean, it does kind of work. Right, so that's just also something. It's the cheapest solution, and why did I buy it? Of course, for experimentation, right? I mean, that's the only reason. Yeah. So, and I actually do remember that when I bought this on the website, was it eBay or Amazon? I don't remember. There was actually even a little warning that says, they warned of this problem, right? It says it's, you got to try it out whether it actually suits your needs, right? But considering the fact that it was so cheap that therefore no optics, no nothing, that, it's the easiest way to connect. Okay, so next thing that I want to show you, and something, another thing, and that is this adapter over here. This is going to be surprising. This one over here, look, it actually doesn't go out, it goes in. Yeah, you also have to fit it in here like this. And this here, this here is a so-called a C-mount adapter, because some microscopes did you not only have this for the eyepiece, but have a so-called a C-mounted adapter. So this adapter is the same one as we have over here. Okay, so you can actually connect in the DSLR camera directly to if your photo tube has a C-mount. Okay, this is of course really compact. And because it is much closer into the tube, therefore you also don't have so much the problem of this black border. Yeah, but again, disadvantage: your microscope needs a C-mount. Otherwise, you cannot have that. Yeah, and yeah. So theoretically, look what I could see. And this doesn't make a lot of sense, maybe, but theoretically, I could even connect this one over here. Right, but it wouldn't make a lot of sense because it makes the image even smaller, right? But I mean, that's all in the, how do you say, in the area of experimentation. Yeah. So, and this was so far this was kind of the good stuff here, right? The practical stuff, which kind of works, which is this one over here, let me reattach it. Okay. So this is the workable stuff, yeah. One of the problems with those is you must have a long enough tube to bring the logo away from the scope, since it sticks out so far on the top of the camera. I see. Okay, okay. C-mount is available for your cheap T2 adapter. Yep. That's another one. Which I don't have, because this one is for the eyepieces, right? And there are, yes, that's correct. There are also those things here where this actually also has a C-mount. Yeah. So you just have to look around. So, but so far this was all now in the kind of in the thing that which is kind of workable and which is kind of And now I'm just going to show you what I directly imported from, was it AliExpress or Banggood or something? This here. This is a massive one. Look, looks pretty neat. Also with, of course, now I took it off again. The T mount goes. Oh, what did I do wrong now? Did I forget a ring or something like this? Yeah, I think there must have been another ring. In any case, that's interesting. I detached something here, which I don't have with me. In any case, this one goes on here. Yeah. Yeah, I forgot this downstairs. Yeah, but in any case, this is not the point. Look at this. I just want to show you something. Maybe you're able to see this. If you actually turn this here, you see this is a cool little diaphragm in here. By turning it, you can open and close this. That's pretty neat. I thought, wow, maybe this way you can actually reduce a stray light or something like that. Yeah. There are only two slight problems with this adapter. Yeah, provided that. Just let me see. Here, that's it. This is how it goes. See, that's the way it goes. Okay. Yeah, and then of course it goes on here. There are only two slight problems with this adapter. I mean, it looks pretty neat actually, and I was really happy. So I thought, cool, maybe by turning this here and the diaphragm opens and closes, and I can maybe reduce stray light. Yeah, it's kind of like a baffle. Again, two slight problems with this. The diaphragm doesn't do anything. It just reduces. It just reduces the field of view. So that's what's the point, right? I want to have the maximum field of view, not have a small circle. And the second thing is it's totally off focus, right? So it didn't do any. I was not able to get it to work properly. Yeah, it was totally off focus, and I couldn't get it focused because it was not parfocal. So honestly, I really tried, but I was not successful with it. Right, so this was actually one of those interesting things where you actually have a piece of engineering which looks quite decent. And the mechanical quality looks just fine. Yeah, but honestly, it don't do anything. Yeah, so for this reason, I mean, I did make a video about this one some time ago, but this is kind of interesting. Yeah. So, and then there are also other solutions, which I also just want to show you. And then actually, and that's in this box over here. But I'm not going to show you all of the details here because I already forgot myself a little bit. Look at this guy here. Wow. Yeah. A whole range of different adapters as well to connect it. Not bad. Look for I don't know, for different size eyepieces and everything. Yeah. Look over here. Yeah. This goes on here. Yeah. And the C mount goes over here on the other side. You get the idea, right? The only problem that I had with those is the following. Actually, no big problems. But because it's also kind of bulky at the end, it was also a little bit of an issue concerning stability. Yeah, but yeah, that was the reason. Yeah, you had to kind of focus it, then you had to kind of tighten it a little bit. Yeah. There is, if it's not perfectly stable, so what I would suggest is that once you've got everything set up, put some electrical tape around it. Yeah. But I just wanted to show you that there are also those solutions, yeah, out there, yeah, that kind of, yeah, where you've got all different sorts of adapters for different size eyepieces and whatnot, yeah. Can you always be sure that your camera is going to stay stable on top of the microscope? Could an adapter snap if the camera is too heavy, or this is generally not a problem? I have to be honest with you, if you connect the DSLR camera directly on the photo tube on the top, it's not a problem. The reason is because it pulls down directly. Where it is a problem is indeed if you try to connect the camera on the side. I don't know, look, let me show you this here. Yeah, I mean, I've got now a small USB camera over here. If you connect the camera over here like this, right? Yeah, can I even show this to you? Yeah, if you connect the camera, you know what? Why not just try it out? Look. So, I mean, even that is possible, but you probably want to have another tripod. Okay, so if you do it like this, I know this is actually an introductory microscope. I mean, it's reasonably stable, right? You don't want, yeah. But you see, if the camera is very heavy or so, then there might be a little bit of strain here, and it might tip over. Yeah. So some people, what I've seen, who have done this, they have actually added another support here on the bottom. However, it is, you can actually flip out the screen and then do microscopy like this as well. I'm just going to, but if you have it actually mounted vertically over here, absolutely no problem. It's really stable. Okay. Yeah. There is definitely no danger, right? This here is a little bit of an issue on the side. Yeah. So, but I know that people have also been trying that. Yeah. So, is a DSLR shot less ideal than a mirrorless camera? Theoretically, yes. Practically, no. I will tell you why. And this is a weird answer, right? Theoretically, yes. Practically, no. Indeed, those cameras, those DSLR cameras, have the following thing: is that there is shutter vibration. So this means if you release it. And if you push the button here, you already introduce a certain vibration. And honestly, even a small vibration is a vibration because the microscope is so sensitive and it magnifies even the smallest shaking. So even if you push this, there is a small vibration, and then you have to. So what I usually do is either use a cable release or you use a timer. So like a 2-second timer, you push the button, right, and then you take your finger off, the camera is steady, and then it will release after 2 seconds. So you don't have this, by pushing the button, the shake, right? However, there might be a tiny shake when the mirror swings open. However, it is like this, that because the camera is heavy and because it is fairly stable on top of the photo tube, generally the vibration is not that strong. However, If you really want to have high magnification, how do you say, images, then even a tiny vibration is not going to make the microscope shake so much, but the liquid, you see, you've got some water in there, right? And then this can shake a little bit. I say for practical purposes, it's not such a big problem, because if the water organisms move anyway, right, then there is a motion blur there anyway. And what you can do, however, is the following. It's also for taking pictures of non-moving objects. Is you actually make the exposure time longer. So what you do is longer, not shorter. Approximately 1/20th of a second is the most problematic shutter speed, because this is how long it takes for the system to stop shaking. So if you have, however, let's say a 2 or 3 or 4 seconds exposure time, then you turn down the light, you make a self-timer for 2 seconds, it's going to open, it's going to shake for a short time, but during the most of the exposure time, it's going to be quiet. Right? So this is actually also a system that people who are doing astrophotography, what they use as well. You use a slightly longer exposure time. I mean, in astrophotography, you have to use a long exposure time anyway. But you don't need, in this case, you don't need see this the shakiness anymore if you expose longer. Yeah. So yes, also possible, indeed. For the Canon camera, you can use the camera software. So if you, for example, take the image, if you don't need very high resolution, what you can do is you actually take either the USB out or the HDMI out, and you feed it into the computer. A little bit like I'm doing right now here. And then you can actually take pictures directly on the computer as well. Or you can control the shutter with the computer, or, and that's also something, is some cameras allow you to actually have a mirror lockup. So this means you can lock up the mirror so that the mirror does not vibrate when it swings up. Okay. So in short, probably the mirrorless cameras these days, they don't have all of these issues, right? But they're still a little bit more expensive, and if you want to experiment around with those, maybe you can get yourself a second-hand DSLR and experiment with those. Yeah. So I will move on a little bit because I do have 3 more things to show you before I want to do actually some worms, as I say, and that's the following 3 things. Number 1. Yeah, let's start with this one over here. These are those cameras which you already know, right? They're the standard USB cameras. And over here, yeah, sometimes there is also, if you're not able to get those into focus, you might want to also, this adapter over here just changes the distance. Okay, so it does not change the size or the diameter, it just changes the distance. Yeah, and sometimes it's called the CSC mount adapter, and it goes on here. Yeah, it goes either into the eyepiece or on, preferably on the photo tube. You've got a USB connector. Disadvantage of those cameras: this is a USB 2. I do not get full frame rate. So that's problem number 1. So the image, the video is a little bit, not as smooth. Problem number 1. Problem number 2, it's not a big problem. You do need the special software to use. However, they do have also special drivers called direct show drivers, which I also have installed so that I can actually use this camera also for live streaming. So other programs are able to access the camera, but it's not treated like a regular webcam. Okay, that's also a little limitation. And yeah, I would say that the slow USB connector is one thing, and of course you always have to have the computer turned on if you want to use this. So that's actually one of the nice things about those cameras here, is I can use them also without a computer. So that's number 1. Number 2. And this is also something that I got an email just recently for someone who actually said that he also got this. This one is an HDMI camera, so low resolution, much lower resolution than those cameras. Okay, but for that you get full frame rate. You need an extra power source here. This is for a menu, an on-screen menu where you can adjust a couple of parameters like contrast. There is also infrared, so you can also have a remote control, which I never use. However, when you buy those, they very often do not come with adapters like this. So either you directly connect it to a microscope without intermediate optics, and then sometimes the image is fairly large because it's not reduced in size, or you buy yourself an additional reduction optics that goes on here. Again, you have got the C-mount over here. So that is actually the one that I'm using for my stereo microscope. Because it's very convenient. And those are useful if you just want to connect it directly to a monitor without a computer. And so we've got this here, we've got this here, and then the last thing here, also an interesting idea, is the following: is a camera without optics, but look where the sensor is compared to this one over here. And that's actually this actually explains the whole thing with this 1 centimeter. Look, the sensor here is pretty much deep down inside the box. Right? Therefore, you need extra optics that not only adjust the size, but also create an image in there. But look where this sensor is. This sensor is, you have guessed, 1 centimeter over here. So it is exactly the place where the objectives pick up the image. So you insert this into the microscope, and it is parfocal. Right? We can actually try this. Let me see if I can. Just a second. So that is, you get the idea. Look, I've got just this microscope. Let's put it in here. Oh yeah, it's a little bit. Where's this? Here, just a couple of cells here, right? So this is it's kind of nice because it's very small. You don't need a photo tube because it's so light. But it does add, because there are no reduction optics, it does add additional magnification to it because it will simply enlarge a small section. And this means that the image looks a little bit blurrier or softer because it introduces a little bit of empty magnification. So the field of view is not quite as large. But it's workable. I mean, So So that's So that's basically this one here. Just wanted to show you this here as well. That's the one over here. So over USB, and very, very small. Generally, larger sensors would be nicer. So that's pretty much all I wanted to show you today. So I did not only show you a couple of DSLR adapters, but also some USB cameras as well. Let me put this back in here. Let me quickly scroll through some of the comments, if there are any. Mirror in DSLR is much worse. Shutters are pretty much the same in DSLR and mirrorless, except for global shutters. Okay, so the mirror, exactly. The mirror is I thought interesting. I thought that the mirrorless cameras these days. I don't have a mirrorless camera. I thought that they have some kind of an electronic shutter, where there is no physical. But maybe it depends on the camera. I don't know. Exactly. The mirror lockup. Is a DSLR shutter less ideal than a mirrorless camera? Strictly speaking, any mechanical thing is less ideal for vibration. However, there's always a big however. The effect, if you tweak the parameters, you won't know. It's not going to be a problem, right? If you make sure it's sufficiently stable, or if you get the correct shutter speed. So, for all practical purposes, I did not have a problem, with the shutter, So I'm going to some of the topics we're just going to save for later. Okay. Could you state some general parameters to look when buying a camera? What should you really be thinking about? There is no... Okay, I think I'm going to answer this now. From my experience... I have to look. Okay, from my experience, there is probably no perfect system. I'm saying it yes, there are some very good systems, but they can be very expensive. So for example, the system that I have right now connected to my main microscope has a Canon D90 without intermediate optics. I have a field of view, it's crazy, which is wider than what I'm able to see in the eyepieces. So I'm actually able to see more through the camera from the area than actually through the eyepieces, because the tube is so big that it's able to catch more of the image than the tube of the eyepieces. However, it's the most expensive one. Generally, what I would say, I'm almost inclined to say, and I'm scared to say that, you gotta do trial and error. Right, I've had so many systems in the past where I thought, this is going to be work, and then it's going to be ideal and it's going to be workable, and then it was simply not practical. Right, it was too bulky or whatever. Right, but concerning parameters, there's one thing which I can tell you: there is no point in buying those cameras with too many megapixels. I know they're selling some of those cameras with tiny sensors and have, I don't know, 9 megapixels or more. The image is not going to be better because of that. As a matter of fact, it could be worse even. The reason why it's not going to be better because the microscope is not able to deliver that resolution. So the camera has way more resolution than what the microscope is able to deliver. So you think that you're going to get a better image quality, but in reality, because they're cramming so many pixels on a small sensor, you have a worse signal to noise ratio. Yeah, and also more, and the images take also longer to be transferred and so on. So I generally would say that if you want to, for all practical work, you don't need more than, I've been working a lot with a 3 megapixel camera, right? But I did a little bit of math, and the 3 megapixel camera is not able to capture the full resolution of most microscopes, but 5 megapixels is. Here, exactly, Jesse, 8 megapixels is enough, 10 plus is overkill. I think these optical scopes have a resolution, yes, depending on the magnification that you use, I once did the math, more than 5 megapixels is wasted. It's really wasted. You will not see a difference. You might as well just take an image with a smaller resolution and then simply blow it up in the Photoshop. Right, so this is kind of the thing that I just want to say. Generally, it's a little bit a question of philosophy. My suggestion is that before you go out and buy anything, I know this sounds ridiculous if I say it, but buy yourself a mobile phone adapter first, simply because it's cheap. You try it out and you're going to see all of the advantages and disadvantages. And if you have been kind of through the whole process, and it's not only with the cameras, it's generally also with microscopes. There's no point in trying to buy the best microscope. No, give yourself the time to run through the process to experience a little bit also some of the limitations of some of the systems, right? And then maybe it's easier to find the system that works best for you. Yeah. The advantage of new sensors is maybe better light sensitivity. Yep. However, higher pixel density, smaller pixel size, less lights per pixel, more signal to noise. Oh no, less signal to noise. My mistake. Yeah. Okay. I'm looking for a camera. The easiest, honestly, the easiest thing is to buy, I don't know, some of those cameras, because they are basically plug and play, right? Yeah, and with the DSLRs, you have to mess around with some adapters. What I'm going to do now is I talked already more than I wanted to, I'm just going to move on to the next topic. Because this was a little bit of hardware stuff. Let me put everything away, because microscopy is not only hardware, it's also a little bit of observation, and I do want to try out feeding the worms. What a way of feeding the worms. Clean everything here, because when you are playing around with specimens and so on, you don't want to have any hardware, any electronics, any optics, anything like that in your area. So let me put this here away as well. I'll do the cleanup later on, this here as well. And where am I right now? I want to show you a little bit. Yeah, I'm just going to show you the worms first, and then I'm going to show you what I have done here. I need to turn on the light. Yes, here they are. So this is a micro aquarium that I made. Yeah, you see, okay, let's do it like this. Let's do it like this. Okay, here, I think that's better. So I think there should be 6 worms. 1, 2, 3, 4, I don't know, 5. Where's the 6? I don't know. Yeah, you get the idea. Yeah, I've had 6 worms here. The gigantic air bubble. And they have been on this slide now for what, 3 or 4 days? Okay. And I've realized one thing, which I just so first again a little bit of the biology last week I also showed it to you, but now you actually see it much better. Do you see this over here? Where is the arrow? Here it is. Look at this bulge here. Do you see this here? This is the head of a new worm growing, and the worm is going to divide here, and then you have this new worm and then the other worm over here. And so you see basically this is a form of asexual reproduction, and they will start to grow a new head here. I'm just going to, there's another one somewhere. This one was the one from before. Here, none here. But I think there were 2 worms which actually were dividing. Here's one. Where's the other one? I don't know. It's you get the idea. Yeah, here. That's the other one. Same thing here, right? Oh, there's yet another one over here. This one is a nice one. Look. There's a 3rd one, which is actually, yeah. So here you actually see it quite nicely. A new head forming, right? Here, right in the middle of the worm, and then the worm is going to divide, and then there are 2 worms, right? So this is, these are called ialosoma worms. They're decomposers. Both of them. So they seem to feel quite happy here. They're reproducing like crazy in the jar. But the thing that I want to show you now is how to make one of these micro aquariums. Yes, I just yesterday or the day before yesterday I released a video on that. I just want to show it to you again. And I want, because they have been starving now on this slide for a couple of days, I want to try to feed them a little bit. I've never tried that. And I want to see if this actually works. So maybe it doesn't work. Okay. But what I have here is the following. I'm going to go over to the desk view here. Let me see. This is a concave slide. And the thing is the following, is I want to make sure, the problem is if I use a regular slide, then many of the worms are going to be crushed because the water evaporates and then the cover glass sticks down and presses on it. I've already crushed several worms here. And so this gives the worms enough distance. And second thing is, you can also add a little bit of food here. So I'm just going to show you what I have done. Yeah, let's move it up again here. What you need is, what is this, Vaseline, right? This is petroleum jelly. Yeah, you just go here and here, get some of the Vaseline out. And the idea is to cover the side here with Vaseline, because Vaseline, of course, is oily, and therefore it will not evaporate. And this is has 2 functions. It makes sure that the cover glass sticks, and number 2, it prevents evaporation of water. But notice I've only added it on 3 sides and not on the other one. The reason being that I'm going to now need a tissue paper to wipe my finger. Okay. The reason being that I want to stick this cover glass over it so that there is a small gap. Almost a little bit like this, and you press down. It's a shaky camera. I don't know if you're able to see this, but it's only covered, I don't know, 75% or so. So there is a small gap here, and this is how you can fill it up with a specimen. And this is also the place when water evaporates, you can actually add more water. Yeah, and so I'm just saying, so this is actually a possibility, and of course oxygen is also able to enter. And this is what I've done, and this is what we're able to see here on the microscope now. Okay, so let's go down again with the The rainbow colors. So that's regular bright field. Yeah, here they are. And over here, what you see over here, that is the Vaseline. Yeah. And they're able to move fairly freely. And you see over here, we've already got an air bubble because it is evaporating. And then in order to prevent complete drying out, what you can do is you can place the slide into a box. Yeah, so I placed the slide in here, and here I added a little bit of water, and then we've got a lot of moisture in here, and then the slide also does not dry out quite as quickly. Okay, but what I would like to try now is, and this is a little bit the experiment now, and where I don't know whether it's gonna work or not, is I want to feed the worms some yeast. And I need to explain this a little bit, what I've got here. I've added a little bit of dry yeast and I stained it with crystal violet. So those tiny dots that you see here actually are the still some yeast particles. And I removed the stain and I washed it and rinsed it with water so that only the yeast is actually stained. Because I don't want to stain everything, right? I just want to have the yeast blue and not all of the worms, right? Because I want to be able to see if the worms are actually eating those. Yeah, and then I really kind of hope that you're able to see the intestine of the worm turn blue as it eats the yeast. Yeah, so that's a little bit blocking water evaporation also blocks airflow. Isn't that a problem? And I will tell you the following: it is not a problem in my view because I exactly left over here this little gap. Okay, and air or oxygen will diffuse in and out, and luckily those worms do not have such a high oxygen requirement. And because they are moving around all the time, the water is not stable anyway, and is also being mixed and basically gets in contact with the air. So I have not found this to be a problem, but that's indeed the reason because I left a space here, because otherwise they might indeed run out of oxygen. Right, so let's give this here a try. So I'm going to do the following now. Is I'm going to add a tiny drop of water. Okay, like this. I'm going to take up some of the yeast, and again, this is a little bit of an experiment now because I don't know if this is gonna work or not. Yeah, and I'm going to switch over to the microscope view. Where's the microscope view? Scope view. And I'm going to now add the yeast, and you see over here, this is a big bubble, what we have here. So that's the water is here, and there is where some of the water has already evaporated. And as I add over here, in the corner, the yeast, the blue yeast, we should actually see that this part here should turn kind of blue. And then I hope that when I zoom in, I'm also able to see that they're actually eating the yeast. I hope. Yeah, I hope that the stain does not kill them. Look, lots of them here. So let's add a little bit of. So watch what I'm doing at the top. Okay, and let's see if this is actually working or not. No? Okay. Let's see that actually. Where is it? Nothing. It's still in my pipette. Okay. Let's see. This wasn't enough. Let me try again. I don't know where. Okay, so yeah, you see some of the yeast clusters are still. Okay. I'm going up a little bit with the magnification. Let's see if this is actually workable or not. Yeah, thank you for the questions. I just see that there is already a slight issue that it doesn't want to go beneath the microscope slide. See, that's one of those nice demonstration effects. Worms over here. Let me focus again. Worms over here. Yeast is over here. Okay, you know what? I'm going to try to mix it a little bit better. That's a little bit sad because I was actually hoping that the yeast is actually going to spread, but it's so clustered together that I'm not able to get them mixed with the worms. Yeah, that's the thing. No space because I was kind of hoping that, you know what, I'm going to try it now the easy way. I'm going to take it away and we're just going to do it here like this. There is indeed not enough. You know what I'm going to do? I'm going to take the liquid out here. If not, you know what? I'm going to do the following. I'm just going to carefully raise it up. And then hope. So let's hope that this was a little bit of a demonstration effect. Yeah, it kind of shows that if there is too much water already present, so I have to find them first. Ah, here's one. Here are a few, and I wonder if they start feeding on those blue yeast particles. If not, see, that's the interesting thing. They are so large, they're still clustered together. Ooh, okay. This guy's already separate because of the. I've done this already with. Almost looks that the stress kind of maybe separated the worm. I tried this already with Daphnia with water fleas, and it worked beautifully. You could actually see how the whole intestine started to turn purple. This is not the head. This is. Okay. Okay, and usually after a couple of minutes, yeah. I've also once fed those worms some potato starch. This was quite fun. You could actually see the potato starch grains travel in the intestine. Okay, so let's give it a couple of minutes, and I'm going to, in the meantime, try to maybe answer a couple of questions. What is the longest time you managed to store live microbes in such a device? I have to show you something. I mean, only for a couple of days, but I have to show you something else. It's down here. I think last 1 or 2 years ago I already have done this. I'm going to show you a real micro aquarium. A real under quotation marks. Okay, let's. I mean, it's kind of interesting. The worm does seem to change colors a little bit from the outside, as if it does absorb a little bit some of the stain from the outside. And there are not a lot of these yeast particles here in any case. So this is a little bit see, there is one over here. I'm not so happy with the size of the yeast because when I tried that before, the yeast cells, they were all separated. And you know what I'm going to do? Just for the, how do you say, fun of it, I'm going to do the following. I'm going to completely remove the cover glass, hoping that the worms are now more or less freely accessible, and maybe they have now more space to move around, and I'm going to show you that. I have to find them if they're still here. Here. Okay. So this is now without cover glass, okay? At least there's one here. Where's the other one? Where are the other ones? Otherwise, we just keep on observing this one here. Here we go. I mean, it almost looks like a little bit like it's turning blue from the outside. Okay, let's give it a little bit of a couple of minutes. I just want to show you one of a real, under quotation marks, a real micro aquarium, a commercial one. That, yeah. I'm going to quickly switch over to the desk view. Okay, this is how it looks. It's called Microlife. Okay, it looks a little bit from the logo like it's a little bit older already. There is a, how do you call this, an instruction manual in here. Then I'll quickly also explain to you how this works. Yeah, this is Paris, Austria, France, Germany. Yeah, this is a glass factory. Which are making microscopic equipment. It works like this here. Look, you can actually place water sample in here, and it's drawn in here, and you can actually observe it here. Yeah. So this is how it looks like over here. So if you add a water with microorganisms in here, then you're they are able to flow in here, and you're able to observe them over here. And because the amount of water is much larger, and because you can actually really close it off, maybe with a little bit of air, I can imagine that you can actually store them in here for quite a long time. Yeah. So yeah, I tried to make something like this as well by using a glass cutter, and but it's very, very how do you say, delicate. Yeah. So, and there are those little screw-on caps. Yeah. So these would be real. This would be a real micro aquarium. But I was able to keep them alive now for a couple of days. Yeah. The more water you have, of course, the longer it will stay alive. Ideally, what you want to do is you just want to keep them in a jar. And then when you do microscopy, you just take out a few of them. Yeah. So very quickly, let's see how they're doing. Again. Oh, that's the wrong microscope. Yeah. This is actually a little bit what we call live staining. Let's see. I have to be careful a little bit. I'm not allowed to go higher with the magnification because there is no cover glass on here. But what you actually see, it's a little bit, the effect is a little bit different because they start to take up the stain from the outside, and that's why the surface starts to stain blue. It's not, yeah, I was actually hoping that they're kind of gulping up the yeast more. Yeah, pipette them out and put them on a clean slide. That I could do, but if I take the slide itself, I think, I mean, all of those particles that you see are still the yeast cells. So maybe later on, after they've eaten something, maybe you can take them out. Yeah. If you have algae inside, can they live forever? I mean, like a closed ecosystem that doesn't need anything other than sunlight. Let's put it this way. Closed ecosystems like so-called mesocosms are very difficult to keep, right? So what happens is that normally when you have a jar with organisms and you either you leave them closed or open, there's always a progression of organisms. So for example, the jar where I got them out was full of Daphnia first. They died off, and then all of a sudden I had the population of those worms exploding. So there is a natural progression, and keeping it stable is already difficult in a regular aquarium. However, those, because there are no big fish or so on inside, generally they tend to be more stable, right? But probably not forever. So So let's wait a couple of minutes. Yeah, now a couple of off-topic questions. I recently bought and used old Kappa TX20 Firewire camera for my Wetzlar V350 just to find that there is no drivers for it. That is honestly, that is generally an issue, right? You buy yeah. So I've got the questions here, right? You have maybe a camera that you want to use, and then there are no drivers for it. I mean, I also had those. I got emails from people who had that problem. So can you always be sure that your camera is going to stay stable? Yeah, I already mentioned that. If it's on the folder tube, generally I would say you have to try it out, of course, with a balance. But the folder tube, because it pushes down, the camera weight pushes down, the microscope doesn't tip over so easily. Yeah. Any plans to do more slime mold experiments? I tell you, I could not revive my slime mold. Yes, the thing is the following. I have grown a so-called sclerosium, basically is a dry form of the slime mold, but I was not able to get it back to life, unfortunately. Yeah, so I've probably done something a little bit wrong. Look at this worm here. It's not eating anything, but it's turning blue in any case. Okay, so hello Oliver, I just found your yes, this is a comment that was I asked my son to include this. This is actually a comment that has been posted yeah, beneath, let me quickly show this to you, beneath one of my YouTube videos. And this is something, it goes a little bit maybe into the slime mold one. Hello Oliver, I just found your channel about a month ago and I've been watching your videos a lot. I love the content you make, thank you very much. There's nothing like it online. It's really impressive that you've been posting consistently for more than 7 years. Could you make more videos on how to grow things at home for observation, specifically on Petri dishes? I worry a lot about safety and I'm really scared of growing something dangerous by accident. Thank you so much for your videos. The reason why I asked to have this question included is because it's an important question. Because there is a reason why I have not been doing a lot of videos about growing bacteria on Petri dishes, not even safe ones. And the reason is the following, because strictly speaking, well, you are allowed to grow biosafety level 1 bacteria at home. So for example, E. coli and so on. Yeah, lactic acid bacteria, which can be found in food and so on. You are allowed to grow at home. But anything else, you are not allowed to grow at home. So you're not allowed to grow any otherwise unknown microorganisms, bacteria at home. So for example, every now and then you see this is basically a school experiment, which actually is a problem, I think, where people take their fingerprints on a Petri dish and then can actually see the bacterial colonies growing. And then you kind of compare it. How does a washed thumb fingerprint look like compared to a dirty one? And then you see that the one that's been washed contains less bacteria. These are, how do you say, experiments that occasionally you see online. However, you should not be doing those. You're essentially growing bacteria on your skin. It could be some infectious staphylococci, also potentially pathogenic. You don't want to do that. And now if I actually show you, and I have done that, I've grown E. coli bacteria and so on, safe ones. However, you can never exclude the possibility that there is not some kind of a, how do you say, contaminant on it. Now, is it likely that this is going to be a danger? No, it's probably not going to be likely. Theoretically, you never know, but it doesn't matter. Strictly speaking, you're already in safety category 2, and for that you need a license, need to be in a licensed laboratory. So for example, I'm a teacher and we're teaching according to I'm teaching according to an international curriculum, and they have very specific guidance also concerning microorganisms in there. and it's actually one of the rules and requirements. If you do experiments with your students, you're only allowed to use E. coli, basically E. coli strains, which are used in laboratories, which are not dangerous. And for this reason, I'm a little bit hesitant, because I'm kind of worried that if I show you now how to make a medium, agar medium with Petri dishes, that some folks out there will actually start growing stuff that you probably should not be growing. So this is the reason why I try to limit my observations to things that are actually pond water samples, worms, as you can see, aquarium, but not on nutrient media, because the bacterial density can be extremely high. Having said that, if you want to grow stuff, I mean, there's plenty of stuff on cheese, yogurt. These are all bacteria that basically can be eaten, right? And if you buy yourself some cheese or some yogurt and put that under the microscope, then fungus on cheese, then it's not a problem, because that's stuff that we're eating anyway, right? So you see, that's a little bit explains this why because it's a common request, why I'm a little bit hesitant about those Petri dishes here, So much as breathing in the wrong direction if you're in biosafety level 2. Even in safe labs, we never opened a Petri dish except in a safety hood. I mean, for example, when I did a long time ago, when I was working in the lab doing my master's thesis in bacteriology, it was biosafety level 2. Right, and this basically meant that we were checked whether our Petri dishes and everything was stored safely. So here it is. So okay, I have to tell you the following. This guy is also not feeling quite healthy. Okay, I just want to show you something. You see this here in here? The stuff that's moving in here, that's inside the intestine. That's actually the stuff that I hoped is going to turn blue. That it's going to eat all of the blue yeast here. But what we've seen instead is that the worm turns blue on the outside. So it's a little different than those Daphnia, because the Daphnia was really pretty. I mean, you could actually see the purple intestine. The mouth, by the way, is this part over here. Yeah, exactly. It seems like I stained everything except that what I wanted to stain. It's correct. I stained the worm, but not the intestine. Here we can actually see it much. Where are the other worms? I mean, there are hundreds of worms in the jar now. Here's another one. This is pretty short one, a small one. It almost looks like it just recently separated. Maybe it did separate as I was kind of playing around, moving it around. But somehow. No, I just want to say, because when I've done this some time ago with potato starch, they gulped up the potato starch, which is surprising, because I actually thought that they're going to eat the yeast. Interesting. So let me quickly see a couple of call it negative staining. So let me quickly go through the whole thing here. By the way, another if you just another thing that I just wanted to maybe show you just very briefly. Of course, if you need a spacer, what you can do, of course, is you can. I mean, I don't have to show that to you because it's kind of self-explanatory. But what you can do as well is you put a cover glass over here, and you put another cover glass diagonally over this one over here, right? So you're also creating a space. I don't know if you're able to see this. So this one over here is kind of. It's now slanted. Also works, however, the evaporation of water is even faster over here. Yeah. Another thing that I just want to mention, and I did not get around experimenting with that yet, because this is again a little bit bacteriology. This is what Robert Koch has done back in the 1900s. Robert Koch, the big important doctor who discovered that bacteria are actually causing diseases. They didn't know that, but he has done the following. He was able to observe bacteria divide using the so-called the hanging drop system. Just want to show this principle to you. What you do is the following. You also put some Vaseline or something like that on here. And then what you do is you take a cover glass. You want to probably put the Vaseline all the way around. Okay. And then what you do is you take a cover glass, and yeah, you know what I'm gonna do? I'm just going to use the how do you say the yeast as my specimen, and then you just make sure that there is very little of this on here. Okay, this is what he has done, very little, and then you turn it around. And this is called the hanging drop system. And what you have now is the following. This is what Robert Koch did to observe dividing bacteria. You now have the following situation. You now prevent water from evaporating, number one. Okay. And you have enough oxygen in here as well, number two. And number three, you have the bacteria or the cells, in this case yeast cells, very close to the cover glass. And this is basically the so-called the hanging drop method. And you can use that hanging drop method to actually observe dividing cells. I don't know, I have to see now if there are a couple of yeast cells still on here. Let me quickly switch over again to the scope view. The worm is still kind of weird. And now I have to find it. Of course I won't find it. Maybe this could be it. I don't know. Yeah, see, this could actually be it. These could be maybe these could be the yeast clusters. Let me focus. See, there's some moisture here. Yes, here it is. Yeah, these are the yeast cells. Now I can go up with the magnification. You know what? I'm going to do bright field so that we can see it better. And that is essentially, this famous hanging drop method to observe dividing cells. Again, preventing evaporation of water. What Robert Koch did is he used actually he used the liquid of a cow's eye. The inside liquid is called the vitreous humor. It's the very protein-rich, very clear liquid inside the eye of a cow. He got this from a slaughterhouse, and he was growing his bacteria in that. And he was able to see them actually divide. And then he discovered that if you infect mice using those bacteria, again, these are yeast cells, so they're not bacteria, but that they are able to cause diseases. So just wanted to show you a little this traditional way as well of specimen preparation. What stain is this? This is, I can show you. This is crystal violet. Just a second. It's crystal violet stain. I've got a whole box of stains here. I've used methylene blue. It's probably easier to get. Crystal violet is pretty aggressive stain because it's look what I've got here over the course of a couple of months. So this one over here, that's the one I used because it's a very powerful stain. So basically all of those blue spots that you see here I cannot. I've got over here saffron in water, very red. It's another red one. Iodine to stain starch. Acetocarmine is also red. I wanted to actually stain chromosomes with that. Didn't work quite as well as I hoped. And this one over here is, that's methylene blue. It's called Löffler's solution. It's not pure methylene blue, but mixed with alcohol and potassium hydroxide. And stains DNA very nicely. Yeah, yeah. I've not used this because there's alcohol in there, and alcohol and living things like, for example, the worms. They don't mix quite well. Yeah? So what I've done is I used this crystal violet to stain the cells, and then I removed the stain and yeah, washed it. So that's basically what I used. Yeah. Toluene blue for the plant stem slices. Now, you know what I'm gonna say. Please do so and send me the pictures. Talking about pictures, I totally forgot that I wanted to show you a few pictures as well. Yeah, because look at this here. This is a picture that was sent to me. Thank you very much. I don't know if you're in the forum right now. This is oblique illumination of the same worm. Oblique illumination means light coming from the side. Okay, and then yes, ever smaller. Jesse sent me this here. Maybe you can talk a little bit about that. Yeah, this is the sensor of what a mouse. Yeah, okay. So that is yeah. I got this. Thank you very much from ever smaller from Jesse, and over here another one. Yeah, this is some electronics. Quite nice. I think what did you say? It's from yeah, that's the mouse sensor. So and yeah, you just mentioned it here. It's a mouse sensor. I bought it cheap on Amazon as a sacrifice. So it was bought, taken apart simply to have a look at the sensor of a mouse. Yeah, which is an optical mouse. Yeah. Yeah, it has both an emitter and the sensors for. So it kind of shows quite nicely actually what you're able to see with a microscope these days. Yeah, AliExpress. Yeah, yeah, $4. Yeah, simply to take it apart. Yeah, so it's a very nice example of a reflected light. Yeah, reflected light imaging. Yeah. And here also thank you for the Iolosoma worm showing oblique illumination means that's a little bit, it looks similar to DIC, to differential interference contrast, where the light is, which gives you somewhat almost a sense that it's three-dimensional. Yeah. So well, let's see how those guys are doing. Where are they? And then I think I'm going to call it a day. Yeah, and yeah. It was enclosed in a chip with a lens. I had to carefully crack it open with some side cutters. Very messy, but managed not to damage the sensor. Yep. Yeah. So I wonder if this are kind of like I don't know, almost like pixels or something like that to detect if there is motion. Yeah. DIC for cheap, yes. Honestly, I've seen in a German microscopy forum a couple of years ago. Somebody who compared DIC and oblique, but he really optimized the oblique. I could barely see a difference. I mean, yeah. So if you really optimize this, this was really of very high quality. By the way, oblique illumination is not a new technique, but even back in the 1900s, they used it. In 19th, yeah, in the early 20th century, the early microscopists also used it because this technique allowed them to see bacteria much better. I suppose their optics was not quite as good, so they used oblique illumination and were able to see bacteria much better. Okay. Ah, yes. Question here. Did you use a compound or a stereo microscope? Okay. Doesn't seem to, yeah. So that's, I also wanted to know that. So for these here, did you just place it on a regular compound microscope and then have some light from the top? Yeah. That would also be possible. Yeah. So where's the scope view? That's again, yeah. Yes. And this is actually then, yeah. You can actually see the, yeah. I used a Matala Studio MT35. I sent it back to Amazon. Okay, yeah, yeah, and here that's basically this so-called the hanging drop system. And let's go back now to the worms. And then I think I'm just going to call it a day. And I have to inform you on something, ladies and gentlemen, guys. Next week, I am unfortunately not around. Look, this worm didn't like it. Okay, this thing the guy. Yeah. Next week, unfortunately, no. How do you say? No live stream. The reason is because I'm not here. Okay, I have to. If you want to know where I am, yeah, I have to. I'm going to spend 3 days in a different place. I have to go with my son there because he participates in a chess competition. He likes to play chess a lot. I've got 2 boys. One of them helps me with the microscope things here, and the other one likes to play chess. And I have to go there because, yeah, and I'll be kind of busy for a few days. And for this reason, I won't be at home to do a live stream. Just to inform you, I'll be back then, yeah, a week afterwards. Yeah. So might be doing a video review of that scope. Oh yes. Okay. So this worm here has given up. Okay, but oh yeah. So I suppose that maybe the stain was a little bit too much for it, and unfortunately, yeah, maybe I don't know. Maybe I don't know if these are kind of yeast cells that it has eaten. I don't know. In any case, it's not quite as clear or as evident as I hoped it to be. A robotic self-moving chessboard. Yeah. And by the way, if you see those, that's why these are called also oil droplet worms, because those round bubbles that you see here are actually fat globules or oil globules. I did try to do a little bit of research how they actually figured out that these are oil globules, and they used some a stain that's apparently they used different types of stains, and then they figured out that these contain a lot of oil globules and oil droplets. I have to tell you, I don't know the function. As always, as oil is energy rich, I suppose it could be some kind of storage, yeah, storage thing. Yeah, usually when I'm, what I'll try to do sometimes, usually when I'm not at home, I usually take along a couple of containers, plastic containers. I collect a couple of samples maybe, and then usually I show them. Yep, he is all into playing chess. So that's usually, I have to tell you, usually I'm a little bit nervous on Saturdays because all of the chess competitions are on a Saturday. Usually in the afternoon, and I always hope that it works out until the live stream. So far, it always worked out, but next week I won't be here. That's yeah, I have to go somewhere. And you know what I'm gonna do now is I'm just going to call it a day, and I'm gonna call it quits for today. Yeah, I'll keep on also uploading occasionally videos. Yeah. And yeah, please check them out. I have, for those of you who don't know, I have got 2 microscopy channels or 2 channels. I've been trying to reorganize this channel right now here. I'm doing mostly microscopy work. The other channel, the main channel called Microbehunter, I'm now trying to yeah, do more like explainer type videos about the microscopic world and biology. Yeah, so this is simply something I just want to inform you that yeah, there is this other channel as well. Yeah, 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 I do have over 10 channels. That is correct, but the some of the channels I've actually made only for students, which are not accessible. So I put some educational stuff on them, simply to some explainer videos for some students, and they're sometimes not. Yeah, they're all set to unlisted. So just for your information, Microscopic Mysteries. Yes, this is a channel that I have not been. I was simply too busy. Yeah. I've been simply too busy a little bit keeping up with all of those channels, but I think for right now I want to keep on doing the live streams, which I also like to do a lot, and a little bit also with your help. If you've got any suggestions or recommendations of what you want to look at, it makes it also get the community involved, makes it also quite interesting. So I'm going to really call it a day now. A day is good because it's quite late already where I am, and I want to wish you all the best. Yeah, A fairy shrimp. Oh, scroll back after the stream. I left a comment about fairy shrimp. Okay. I bumped now. Yes, I will do that. Okay. Fairy shrimp. Maybe I'll do the following. That's another thing. A couple of years ago, I did some Artemia salina, those so-called the sea monkeys. I might have a look at those again. The sea monkeys, hatching sea monkeys, they're also quite fun to observe. I think it's been already 2 or 3 years since I've done them last time. So maybe that's something that's also a little bit on the plan. Okay, I wish you all the best, folks. Happy microbe hunting, and see you hopefully again in 2 weeks or so. Okay, bye-bye, all the best.